Everyone, I'm Dr. Rao. I hope you guys are doing well. Welcome to my YouTube channel Mathematics by Dr. N. Rao. Today I'm going to deal with another tutorial based on the Newton-Raphson method, which is a very interesting and very uh, fast method to compute the root of a nonlinear function. Okay, so guys, before going to the further study, once again I request you to subscribe my YouTube channel and like the videos and share among your friends also, and comment in the comment box, press the bell icon to get the further notification. So guys, Newton-Raphson method, if we talk about the formula, so it is very simple. Okay, and it is a very beautiful method also, Newton-Raphson method. Okay, Newton. And for the rest of the methods like bisection method, regular falsi method, false position method, or method of course, you can see the videos in the playlist also based on these tutorials. So Newton-Raphson method. Okay, Newton-Raphson method. Here we will learn only how to compute this method into the calculator. Okay, so the method is, we will not learn here the development of the formula, and we are also not interested in the development of the formula. We just interested in the formula and its computation. Okay, so f of xn and divided by derivative of the xn, right? So for the derivatives, you can see the video, fundamentals of the derivatives. Okay, I have uploaded one another video based on the derivatives and fundamentals of the derivatives. Come on. So it is the formula. And it is very simple to compute. For example, if somebody say find the value of x e to the power, find the root for x e to the power x minus 1. Okay, for this function, find the root of this function with the help of Newton-Raphson method. So obviously it is your fx, so you need to require the derivative of that. As I have told you, I have uploaded another video on the derivatives of the functions, so you can see there. Okay, so derivative, dash means derivative, and x e to the power x minus 1. So come on, here two formulas, two functions are there, and these two functions are in product. So you will apply here the quotient rule. Remember, it is the constant term and the derivative of the constant term is 0. So I am writing it here 0, right? So I need to differentiate only d by dx, x e to the power x. Okay, so come on, what is the derivative of that? So first function, then the derivative of the second function means d by dx e to the power x, right? And then plus second function and the derivative of the first function. Okay, so you will compute it as x e to the power x and then plus e to the power x into 1. So it is e to the power x, you can take common outside, x plus 1. So it is your derivative. So according to your formula, okay, so according your Newton-Raphson formula, what will happen, you will write it x n, oh okay, or in place of x, and I'm interested to write x. Okay, whenever you are writing in your examination, so write in terms of xn plus 1, because it is an iterative formula. Okay, x0, x1 will come in terms of x0, x2 will come in terms of x, x3 will come in terms of x2. So that's why we are writing a recursive relation here. Okay, in terms of n. But for our computation in the calculator, we will write it simply as x. So what about the fx? Fx is given here, x e to the power x minus 1. And what about its derivative? And its derivative we have calculated here, e to the power x, x plus 1, x plus 1. Okay, so you need to compute this in your calculator only, and the work methodology is very simple. Remember this point, very simple. Okay, I'm going to off the screen of the my laptop, and now for the better visuals. Okay, so come on, now I need to type first x. So remember, in your calculator, x either it will be printed on or just above the key. Okay, it will be there, of the alpha color means maroon color. Okay, so see this one. So don't bother. If it is printed on your key, then it will be simply come by pressing the key. If it is not the case, then you have to go with the alpha sign, this close C bracket, and X will come. Now, very good. Now press the minus sign here. Okay, X minus. Now take the numerator and denominator symbol which is printed on the key here. Simply. Okay, now type fx here. Fx means x, then e to the power x. E to the power x is of the color of shift, right? Then press shift and then ln symbol. So e to the power box will come here. So compute here x once again, and then with the right arrow you have to down your cursor here. So minus. Okay, for the denominator with the down arrow you have to transfer your cursor in the denominator by the down arrow, and here you need to write e to the power x in bracket x plus 1. So again e to the power x is required, so press shift this one and type x here, then with the right arrow down your cursor, and then write the left and right arrow, left and right bracket, right C bracket, and type here with the right arrow, come in between this bracket, and then x plus 1. Now your Newton-Raphson method is computed. Okay, although pressing the equal sign, it will be stored here and it will show you some value, but this value is due to the default values or some other values is stored in your calculator. So we are not interested in this value. Okay, and it is not our answer. So initially you can start from anywhere in the Newton-Raphson method. Okay, initially, for example, I am taking the value for x. Okay, I will press to compute the new value of x. You need to press calc sign, not equal sign. To pressing the equal sign, it will give you the answer. To pressing the calc signs, it will ask the value of the variable here. So when you press x, so it is showing some another value which is already stored in the calculator. We are not interested in this value, although we can compute here another value 2 1 2 3 4 5 whatever. Okay, so I'm interested to give it 2 as x equals to 2. Now come on, now press equal to get the answer. So my answer is this. Very good. It is my first iteration. Now I want to find the x2 second iteration. It will be in terms of x1. Now x1 value is this one. Remember this point. So you have to store this value in x once again. Okay, so for doing so you need to store sto store. Okay, this answer into the x. What is the process? Okay, in some calculator it is just printed on the key, and in some calculator it is printed just here upon the key. So if it is printed on the key, then it will come simply press sto and then this bracket, this one, it will come directly, not a big issue. Now this answer is stored in x. Okay, now if you will go to the with the upper arrow with the Newton-Raphson method functions, then you will press x, so you will get the new answer. You will get the new answer. Okay, in some calculator it will be sto will be printed here, so you will press first shift, then sto, then this one. Okay, then answer. Okay, then answer will come in x. Okay, and then go to once again to the function with the upper arrow, you will get the new value. Again you have to press this one and go to the, you have to repeat it until the desired accuracy root is obtained. Come on, keep pressing it. The work methodology is very simple, guys. Work methodology is very simple. Your calculator will do all these steps, okay, every time. And I think all the decimals are repeating here. Your answer, your root of the function has been repeated up to around 11 places. I think 2, 4, 6, 8 and 9 places in just 4 to 5 steps. That's why the Newton-Raphson method is too strong to work. Okay guys, so thank you very much for watching the videos. We will meet in the another tutorial of the numerical methods.